This is JS Party, your weekly celebration of JavaScript and the web. Check us out on the web at jsparty.fm. There you'll find our recommended episodes, listener favorites, and a request form, so you can let us know what you want to hear about on the pod.
That's a great idea. I'm glad I had it.
Thanks to our partners for helping us bring you world-class developer pods each and every week. Fastly.com, Fly.io, and Typesense.org. Okay, hey, it's party time, y'all.
What's up, friends? I'm here with one of our good friends, Faraz Abukadije. Faraz is the founder and CEO of Socket. You can find them at socket.dev. Secure your supply chain, ship with confidence. But Faraz, I have a question for you. What's the problem? What security concerns do developers face when consuming open source dependencies? What does Socket do to solve these problems?
So the problem that Socket solves is when a developer is choosing a package, there's so much potential information they could look at, right? I mean, at the end of the day, they're trying to get a job done, right? There's a feature they want to implement. They want to solve a problem. So they go and find a package that looks like it might be a promising solution. Maybe they check to see that it has an open source license, that it has good docs. Maybe they check the number of downloads or GitHub stars. But most developers don't really go beyond that. And if you think about what it means to use a good package, to use a good open source dependency, we care about a lot of other things too, right? We care about who is the maintainer? Is this thing well maintained? From a security perspective, we care about, does this thing have known vulnerabilities? Does it do weird things? Maybe it takes your environment variables and it sends them off to the network, meaning it's going to take your API keys, your tokens. Like that would be bad. The unfortunate thing is that today, most developers who are choosing packages and going about their day, they're not looking for that type of stuff. It's not really reasonable to expect a developer to go and open up every single one of their dependencies and read every line of code. Not to mention that the average NPM package has 79 additional dependencies that it brings in. So you're talking about just, thousands and thousands of lines of code. And so we do that work for the developer. So we go out and we fully analyze every piece of their dependencies, every one of those lines of code, and we look for strange things. We look for those risks that they're not going to have time to look for. So we'll find, we detect all kinds of attacks and kinds of malware and vulnerabilities in those dependencies, and we bring them to the developer and help them when they're at that moment of choosing a package.
Okay, that's good. So what's the install process? What's the getting started?
Socket's super easy to get started with. So our whole team is made up of developers, and so it's super developer friendly. We got tired of using security tools that send a ton of alerts and were hard to configure and just kind of noisy. And so we built Socket to fix all those problems. So we have all the typical integrations you'd expect: a CLI, a GitHub app, an API, all that good stuff. But most of our users use Socket through the GitHub app, and it's a really fast install. A couple clicks, you get it going, and it monitors all your pull requests. And you can get an accurate and kind of in-depth analysis of all your dependencies. Really high signal to noise. It doesn't just cover vulnerabilities. It's actually about the full picture of dependency risk and quality. Right? So we help you make better decisions about dependencies that you're using directly in the pull request workflow, directly where you're spending your time as a developer. Whether you're managing a small project or a large application with thousands of dependencies, Socket has you covered, and it's pretty simple to use. It's really not a complicated tool.
Very cool. The next step is to go to socket.dev, install the GitHub app, or book a demo. Either works for us. Again, socket.dev. That's socket.dev.
Hello all of our JS Party animals. I'm Jerod, your internet friend, and I'm joined today by my friend Amal.
Hi, Jerod.
What's up, Amal?
I'm good. I feel like podcasting has now become like my, I'm just going to go to the grocery to pick up something for dinner kind of thing, where I feel like I've been on the show so much recently. I'm just like podcasting I'm podcasting twice this week. That's insane.
Oh my goodness.
I know.
You're like a pro podcaster now.
Yeah. I'm entering into the realm of Jerod and Adam, so we'll see.
There you go. Pretty soon, people will be sick of you.
I know.
Like they are surely sick of me at this point. Well, today we have an awesome topic. This is a requested topic, sort of. It's a requested guest for sure, Gregg Tavares. Welcome to the show, Gregg.
Hello. I'm happy to be here.
Happy to have you, the author of WebGL Fundamentals.org. And I'm sure you have many other things that you do as well. This show requested by listener Daniel Buckmaster wants to talk about WebGL. And so I thought, hey, I don't know much about WebGL. I'll email Gregg and see if we can talk about WebGL. And he said, I'd love to come on the show. Are you sure you want to talk about WebGL? Because WebGPU, that's the new hotness. It's going to be replacing WebGL 2 or kind of has. I don't know. You tell us what you told me, Gregg, and why we're going to talk about WebGPU today.
Right. Well, WebGPU shipped in Chrome in May, and it's going to be shipped in the other browsers as soon as they get it ready. Whereas WebGL shipped, I think it's 12 years ago. So
old and busted? Is that what you're saying? It's old and busted.
It's not old and busted, but it's definitely done. You know, I mean, there might be some minor modifications, but they're like, it's time to move on.
Right.
And WebGPU is the direction I think everybody's hoping will go.
And it sounds like it is going that direction. You said Chrome shipped it. It's behind a flag, I believe, on Firefox and Safari. Edge, of course, Chromium-based, has green support. I'm on caniuse.com. So, like, it's becoming a thing, right? It's not going to be a flash in the pan.
It should not be a flash in the pan, no. There's a lot of people using it, a lot of different companies. I think Unity announced they're supporting WebGPU. I don't know if they've actually shipped anything other than a beta, but I'm pretty sure they announced that. If not, I'm in trouble.
Breaking news.
No, I'm pretty sure they announced that. And I know other people working on other things as well.
Okay. Well, tell us a little bit about yourself. Obviously, you made this website, which is a comprehensive, guide to WebGL. What's your background? What are you interested in? And how did you come to create this website and be interested in these technologies?
I am actually a game developer. At least I used to call myself a game developer. I'd like to still consider myself a game developer, but the fact that the last game I wrote is 2007 kind of suggests that maybe I should reconsider that title. And I actually came to Google in 2008 to create a game engine.
Okay.
And that was called O3D. You can look it up. It is probably doesn't look quite like a game engine, but it was released and then promptly canceled.
Aw.
Google's never canceled a project they've released.
No, that's new. That's new. You're the first one.
It was totally the right decision. And I ended up working on WebGL, which was the correct replacement. It's more flexible, lets people write their own engines instead of having to deal with ours. And that was a better decision. And for whatever reason, I started answering questions on Stack Overflow. And one of the problems with these kind of GPU APIs is they require a lot of setup. So you can't answer it as quickly as you can answer most web API questions. Like if you want to draw a circle in with the Canvas 2D API, it's like you have a canvas, you create a context, you call arc, and then you call fill, and you get a circle, like 4 lines. No, it's like, 70, 80, 100 lines to do that in WebGL.
Draw a circle?
Yeah, I don't know how small I could get it, but it's definitely not as small. It's very low level. It's like assembly language compared to a library. So people write libraries on top of the of technology like WebGL and WebGPU. And if you're smart, you use one of those. If you're a glutton for punishment, then you go your own direction and do it all yourself.
That's pretty cool. Just to confirm, so WebGL, like the actual web standard, is something that was driven by Google from the work that you were doing. Is that correct?
So no, I would say I'm going to get these messed up. It was either somebody at Mozilla or somebody at Opera, or both of them together kind of pushed for a WebGL at some point. Somebody, not me, decided, yeah, that's the right direction. Let's go that way.
I see. And how long has WebGL been a thing?
I think it shipped in 2011.
Okay.
So we started working on it before then, but I'm pretty sure it shipped September 2011. I'd have to go double check.
Wow.
It's been so long. I don't remember from yesterday.
Yeah, no, that's pretty cool. And so now it's like on its next evolution, hopefully to be replaced by WebGPU, like you were saying.
I think that would be the way to look at it. There's still some trade-offs at the moment, or try to get rid of those. So anyway, I want to finish a little bit. Back to that other story. So what happened was I would answer questions on Stack Overflow, and because the amount of knowledge you need to use it effectively is so large, you couldn't really answer a lot of the questions in the small format of Stack Overflow. So I was like, okay, fine, I'll go write some articles They originally were on my blog. After about 5, I'm like, okay, I should probably move this somewhere else so maybe somebody else can contribute or fix bugs or things like that. And it turned into WebGPU or WebGL Fundamentals.
Yeah, that's very cool. I'm super curious about this because there's been this like huge barrier to entry with WebGL, because it's kind of like, I don't even know. I feel like you need computer brain to like effectively use it. Like I always feel really like dumb and like I'm like, why can't I visualize a matrix in my head? Or like, I there's all kinds of stuff, and I so I'm just curious, like, can you talk a little bit about that friction? Because there's, when you're designing a spec, obviously, like as a spec author, there's a level of bias that you have, right? Like because you're like the expert on this thing, and so like how do you get feedback from people to say like, is this thing easy to use? Right, because I can count on one hand, and I can count on my one hand. It's one finger out of my huge network of the people that I know that are actively using this. So
yeah, there's a bunch of answers to that question. So one is WebGL was based on OpenGL, which means it wasn't. It was an existing standard, and WebGL's goal was just like, how can we bring this to the web? So they didn't really have the opportunity to redesign it. They were like, let's go with an existing standard, and then all these things that are using that standard will be easier to use. Whereas if they wrote something entirely new, all those things would just have to start from scratch. So I think that was the thinking. So outside of the web, there's OpenGL, which has been used since the early 90s. And lots of native apps use OpenGL. It's still popular on phones, as far as I know. And I think it's still popular even on desktop for some apps. And so, yeah, WebGL kind of had their hands tied. If their thinking was we're going to bring OpenGL to the web, then they couldn't really redesign the API. All they could do was make it safe for the web and try to make it webby where it needed to be.
yeah, that makes sense. Thanks for sharing that context. That explains a lot, So this is like a leaky abstraction in the worst of ways, where it's just like, here's the JavaScript way to use this really complicated thing that was complicated to begin with,
The other way to look at both of these APIs is they're kind of like WebAssembly, where they've come out with this thing called WebAssembly or WASM, and you don't generally write WASM, you use some other tool like Inscription, or Inscription lets you write C++, and then it translates it to WASM. So C++ programmers can, write web code if they want. You see like all the emulators, like if you've ever gone to, I think the archive, and you look up Commodore 64 games or Apple II games, right? They're all running through WASM, which are running an emulator that somebody wrote for native, and they just recompiled it. So yeah, most people don't write WASM directly, and in the same way, most people probably don't write either WebGL or WebGPU directly. They use a library. The most popular one is probably 3JS. Another popular one is Babylon.js. There are also, if you're using Maps.gl or Google Maps embedded, those use it for you. You don't have to do anything. You're just doing something at a higher level. So that's the most common way to get those things in, get usage, right? You don't do it yourself.
Here's how you know you're low level is when you have a higher level abstraction called 3JS that people also write higher levels for, right? Like 3JS, which I have used and has not too bad of a learning curve, still has one. There's some verbosity there and some things to understand. And that's on top of this. So you guys are down there. Why so low level, and why these technologies in general? You mentioned gaming and then Google Maps. So like, what are the use cases beyond maybe those two examples, or in addition to? And why so low level? Like, can you not bring it up a level for even the library authors?
Well, the reason it's low level is because you get all the speed from being low level. So you can optimize your solution for whatever you're trying to do. As far as examples, like the hotness nowadays is machine learning, which uses these APIs. Also, like everything on your display, your browser, all the text in it, all these camera images we're seeing, those are all done to the GPU. The browser handles it for you, and there are high-level APIs to do it. But if you want to do it yourself, Google Maps is an example. That one's all WebGL at the moment. I'm sure a WebGPU version is being worked on. Haven't seen it, but it goes without saying that it has to happen. So it's basically the basic technology of getting anything on the screen nowadays is these low-level APIs. And there are A good example, I don't know if this is a good example. Let's see. Back when Chrome shipped, Chrome used the CPU to render, and they had a fast renderer, and it had its impressive demos. I don't know if you remember. They had like these bouncing ball physics demos that they showed off, and it was pretty neat that it ran fast at the time. Then all the OSs and the browsers added GPU rendering. Using the GPU itself will draw triangles for you, and based on that, you get all the stuff you see. Triangles with textures on them, so with images in them. And that's mostly how stuff works today. But lately, using something called compute shaders, which just lets you kind of do generalized computing on GPUs, there are newer algorithms that take it even further. So there's a library called Velo, which you can look up. I think it's called Velo, written, that does structured graphics, like SVG type of stuff. And you can use to render UIs and things like that. That's using completely software rendering. Software meaning that, I don't know how to say that. They're not asking the GPU to use its older rasterizing functions. They're actually computing the pixels themselves. This is like a progression. Another example is I think Unreal has a renderer called Nanite, and they're also doing new techniques where they're rendering things themselves in ways that just 5-10 years ago were very less common.
Yeah.
So we gave you a higher level API, those things wouldn't be possible.
Makes sense.
It's like if we only give you SVG, you can't do the lower level things.
Yeah.
That's really cool. So I kind of want to take a few steps back, and maybe we can use this Google Maps app that everyone's very familiar with to kind of walk through like, okay, I'm an engineer on Google Maps. I have a ticket that's landed on my in my queue that's like, all right, here's a spike to explore and estimate what it's going to take to convert from our current implementation, which uses WebGL, to WebGPU, right? So here's a spike to go investigate. Like, what's the effort? What's the gains? What's the migration path? What's going to break? What works across what browsers? How do we how do we handle this gracefully so that we can progressively update? Walk me through that spike, because, that's a very real use case that a lot of engineers have to deal with. Like, even within tools like React, for example, I remember back in the day when I was I think I did the React 16 upgrade for my team, and, we just had to figure out okay, how this is going to impact us. And so, so can you walk us through that?
That is going to be hard.
It's going to be it's going to be like a bullet pointed answer, right? I get that.
Well, he already did. That's his spike. He spiked it out. It's going to be hard.
I love it, Jerod.
Well, I don't know, it'd be easy to understand. An easier, I think, to me, a more interesting one is when they went from the old Google Maps where it served tiled images to the new Google Maps where it used WebGL. And I don't remember if there was one in between. But that was a huge change, right? Because it went from these pre-rendered tiles to a system that, when they announced it, they pointed out they can change whichever roads are labeled or which roads are highlighted, or they can show different things, all because they switched to dynamic rendering. And I think at the time they were they couldn't do it with the 2D Canvas API because it was too slow. But if you go into Google Maps now and you zoom in and out and you move around, if you're lucky, everything always runs just butter smooth.
It's impressive, actually. I have to say it's one of the Google products that I use almost every day. I love, and I've now converted my phone to I have an Apple device. I had an Android for many years. I was an OG Android user. I had the Droid, Motorola Droid, all the way to the Pixel 3. And then I was just I'm done, for lots of reasons, which maybe we can have another show about. But now that I'm an Apple user, obviously, who wants to use Apple Maps, right? Because I can always reliably use Maps on web, on any device, and it works. It's really, really good.
Sounds like it's a prime candidate for cancellation. Greg, do you think they're going to be done with? Isn't it time that they just close that project down?
No, but I feel people should know Maps uses tools like WebGL, and I think more so I wish it wasn't closed source, because it's I would love to see the engineering behind it,
Yeah, that one, it's probably going to stay closed.
It's probably gnarly, I'm thinking.
It is probably pretty gnarly, and it's one of those things where there's petabytes of data, probably.
Right.
They did something recently where you can actually pull the data out and use it in 3D libraries, and there are examples of using it in 3JS and Babylon and Unity and other things. So maybe that'd be more relevant to see that source now. I have no idea. I haven't looked. As for WebGL to WebGPU, nowadays this is my personal point of view, I guess, but there's like 3 or 4 major graphics APIs. There's OpenGL, there's Vulkan, there's Metal on Apple devices, and there's DirectX 12, 11, 12 on Windows devices. They're all different, but at a certain level, they're all the same. So porting from WebGL to WebGPU, depending on how you look at it, is just a matter of, okay, over here I call Phil Rect, and over there I call Rect Phil. It's not that simple, but at a certain level it is.
So what's the advantage then? What I want to try to understand is, as an engineer, right, there's 2 things I care about. How this thing performs, how this runs on the Metal, how does this perform in the browser, right? The other thing I care about is the usability of the API, right? So like, what improvements do I get from like using this? Like, is there a velocity increase in my productivity as a developer when using WebGPU? Or is it still the same complicated like API?
They're all complicated. They haven't gotten less complicated. Okay. The difference is new features have been added that aren't available in the old APIs. So those new features can enable huge new features that you couldn't do before.
Okay.
So is there any reason to write WebGL today?
So yes, unfortunately, these new features require new hardware.
Okay.
So if you're targeting a market segment that is using very old hardware, you might find that WebGL reaches more users than WebGL 2 or WebGPU.
Gotcha.
Those users that have these old equipment go down all the time. You can also decide to fall back, like in Google Maps. It will run without WebGL. It just goes into a mode that loses some of these features. Like you can't go in 3D, the roads and things like that might not get as dynamic. It doesn't run at 60 frames a second or as smooth, but it still runs. Kind of like, you can still get I guess they're deprecating that, but you can still use the HTML, the plain HTML version of Gmail, right?
Yeah.
Versus the full app version.
For now.
Yes. For now, yes.
It's so funny. I wonder if there's like an old .gmail.com,
like old Reddit.
Where you could forever use the HTML version, like Reddit. Yeah. So I guess here's the thing, like, I think for me, like, this seems like a perfect use case for a progressive experience, right? Where like you have like, here are the old APIs, here's the new ones. We have a code base that's going to live side by side until the hardware catches up more universally, or something like that. But I feel like there's definitely a marketing problem for WebGPU, right? Because if it can't run on all the same devices as WebGL, like, what's my incentive to like spend the engineering time on this, right? Because I'd have to maintain 2 code bases, or 2 implementations.
Well, I think you have to look at your particular market and decide whether the percentage of people who have these old machines are something you want. Because let's say you're making a game. Maybe no matter what you do, that game is just not going to run fast enough on their machine. So, then there's no reason to target that old stuff, as an example. So it kind of really depends on what you're making. I don't know if I have anything else to say there.
Yeah.
But
Yeah, no, that makes sense.
What you're making and where you're starting. Like, are you starting fresh and what are you targeting? Because I would actually come from the other angle. Like, I would be like, why not WebGPU? That's what I would first ask myself. And if the answer is, well, because I need to support these devices, ongoing, well, then that's your answer. But otherwise, I'm looking forward and I'm seeing support coming along for WebGPU. And I'm thinking, why WebGL,
Another example is maybe the thing you want to do, just you can't do it any other way. So WebGPU gives the web page access to something called compute shaders. They're not available in the other APIs. And, like machine learning is pretty much compute shader based. So if you want to do like large language models in the browser, there are ways you could coerce it into the older APIs, but yeah, basically the thing is you should probably want to use WebGPU.
Yeah, that makes sense. And so I'm curious, like, since these things are going to be living side by side more or less indefinitely because of the arc of the web, are there features going to, like, I guess, is WebGL is there deprecation for WebGL? Because
I don't know if we'd use that word yet. I just don't think there's going to be a lot of effort. All the people on the browser teams that would work on the 2 APIs, they're the same people working on both. And so they only have so much time and they all want to move forward. Like if they had to split their time between the both, that would be a huge drain. So
new features probably will exclusively be added, like likely exclusively be added to WebGPU.
That is my guess.
Okay. That makes sense.
So if most of us plebs are using this via libraries, are the libraries then being ported? So like if I'm on 3JS and I never wrote a line of WebGL, Can I just be like, hey, 3JS, switch to WebGPU mode, and I get to use that now?
Pretty much, yes.
Awesome.
It's pretty cool.
No more questions.
Yeah, we're done. We're done now. End of podcast.
all you need to know,
Okay,
yes.
no, actually, I do have questions about this API. So can you talk us about what's new? You mentioned one of the shading things, and that's the term, shading things.
So, well, let me try to make clear. Yeah. These APIs basically just run functions on the GPU. And that's where all the complications comes from, because my analogy I like to use is there's functions like map and reduce where you give them a function to run and they run now. So imagine you could transfer that function to another machine and say, run it over there. But in order to do that, you also have to transfer all the data over to the other machine. And then you need some way to tell that function, okay, how do I find the data? Where did you put it? What is it called? What format is it in? And that's where the complication comes from. So in the older APIs, well, I don't want to put it that way, in both APIs, there are something called vertex shaders, and these compute vertices on the screen, just positions to draw triangles. And whenever a triangle is computed, there's another function called a fragment shader. And as that triangle gets turned into pixels, it goes along and it says, okay, I need to draw a pixel here, a pixel there, a pixel there. It calls the second function, the fragment shader, to say, what color should I make this? And you tell it. And you provide a function to figure that out. And yeah, then in WebGPU, there's also a compute shader. A compute shader is just a function. You say, call this function this many times. And that's all you get. You get an iteration number in the function, and the rest is up to you. Use that iteration number to index into arrays, to write into arrays, to do some computation. But the complication comes is that you have to write these functions in some other language that's not JavaScript. You transfer them over to the GPU, and then you have to transfer all the data and then wire it all up. And in WebGPU, that all happens by index. So you say, at index 1, I put this data. At index 2, I put that data. At index 3, I put this data. And in your function, you have to say, okay, this array number 1 comes from index 12, and array number 9 comes from index 3. And that's where it turns into more code than a higher level API. And then generally you don't want to deal with the numbers, so you're going to write something much higher level for yourself so that you can deal with names and all that stuff. But underneath you have to wire it all up.
Yeah, and this is why this honestly
Gregg's
makes
down there underneath wiring it together.
my brain is exploding right now. Honestly, this is true. It's
Right.
it's triggering feelings that I had when trying to play around with this a few years ago. So I guess for me, is it safe to say that WebGL and WebGPU are kind of it's like rendering on steroids, because HTML assumes this document type structure. And, in the world of the WebGPU and WebGL, it's, everything is just kind of I don't know, it's you're in the matrix and there are no linear shapes or whatever, right? And so I don't know, it's just it's really cool that we can do this type of rendering in the web,
Yeah. I'm not sure what the question was already,
Yeah, no. I was just I was curious to see is this, how would you compare this to kind of the HTML rendering engines essentially, right? So,
well, I guess I would compare it. The easier comparison is SVG versus Canvas, right? In SVG, you declare this hierarchy of elements, and then it renders it, and you can update the elements, and it'll update it. That's very similar to the DOM. In fact, it is a DOM.
Right.
Versus the Canvas API, where you just call these functions to draw, and they just put pixels in a rectangle, and there's no structure anymore. There's nothing left there.
It's more imperative versus declarative, right? So with
Right.
HTML and with SVG, you're declaring the shape of a thing. But with this, you're actually giving it instructions on how and where to draw and when and to update, etc.
Yeah, except that, again, WebGPU brings in compute shaders. So now it's just, I want to do random computation. It doesn't have to be about drawing.
What up, nerds? Jerod here. If you listened to our React Jam episode at the end of October, you already know that I judged their fall competition and had a great time doing it. So many cool games. Rock, Paper, Shoot was my favorite, a modern take on two classics, Rock, Paper, Scissors meets Pong. If you missed the fall competition, no worries, because the Winter React Jam is taking place December 26th through January 7th. And yes, I will be judging once again. So get involved, it's a ton of fun, and there's cash prizes too. Learn more at reactjam.com. Once again, that's reactjam.com. Let's do this. The whole machine learning thing, I think, is definitely interesting. It's also concerning, I guess, for me as a guy who visits a website on my phone and all of a sudden it's machine learning in my browser on, like, there seem like there's security and privacy concerns with this. Isn't there?
Yeah, that is a good question, and I have no idea.
Okay.
I can't tell you, I think, pretty positive this is true. If you go into a video chat app like we're in now, and it has the options to replace the background or, put a hat on your head or eyeglasses on your face, that's all compute shaders type of stuff.
Right.
They might be using WebGL coerced into kind of doing the same thing a compute shader would do better because they didn't have compute shaders until now. But those kind of things are things that are common to use the GPU for.
Do those things usually require permission or explicit from the end user of yes, you may use my GPU or no?
Not currently. Maybe some browsers have that option to say, hey, just don't allow pages to use this.
I mean, most people won't know what that is, but
right.
You go to a website, it's doing some inference inside of your browser and your phone starts to get hot and you're like, I didn't know you were doing inference inside of my browser,
Yeah.
That's what I mean by that's not really security. I don't know what it is. It's like abuse to a certain extent.
Yeah, that's a good question. I don't know that it's worse with GPUs than CPUs, right?
Well, just because of this new use case of compute
right.
versus. Oh, I see. I thought you were saying WebGPU versus WebGL, but yeah, you could do it with a CPU, I guess, already.
You could spawn a bunch of workers and do a whole bunch of work on the CPU. It's not like it adds a new capability.
There's plenty of ways to abuse your end user out here.
Hopefully, it's either, hey, every time I go to the site, my battery goes down. I'm not going in there anymore.
I'm not going to go there anymore.
Don't reward bad behavior.
Right.
It's hard to know these days. I mean, there's so many battery draining apps.
Yeah, that's true.
But it does bring up an interesting ethical question, though, which is, should there be some type of user consent for heavy compute, right? In the where it's hey, this is your device, this is your battery, maybe you're in an airport, maybe you're in a train station, we imagine going to a website and just having 10% of your battery drained in 5 minutes, that would hurt, And so I'm curious, any thoughts on that, Greg?
I'm not the person to answer. I would ask what's the difference between that and a native app. You go to the native app and it starts using whatever features it wants.
Yeah.
I
would say this applies probably across the board, just in general, right? It's just in general.
I would say that there's a sentiment that when you visit a website that you're not giving it what you're giving a native app. I've installed you, I'm launching you from my desktop versus I follow a link off of x.com to a new website and all of a sudden it's there's less, I just feel like it's more lightweight. It's the web. You got tabs and you close a tab, open a tab, visit a website, hit the back button. It doesn't feel like you're giving it native app experience unless of course you install it as a PWA or something, which is all good. So it does feel slightly different. But that being said, when I open up Google Maps on my phone inside of Safari and I'm using that, I understand it's doing some heavy stuff inside of there. And so maybe it's not super a problem. Definitely not one that Greg has answers for. He's made that clear. So we're just kind of talking out loud here.
We'll just speculate on your behalf, Greg. It's fine.
Which is what you do usually versus...
Well, I mean, yeah, speaking for myself, right? A lot of native apps are just a browser. And even if they're not, they're probably using some ad library and they get updated every week. And you don't know that what you installed when you install it is the same thing you're running now. And the ad libraries are a third party, so they could have added something to it. It's not really that different of experience. I know that it seems like it, but if you actually drill down to the tech, you're not actually getting a different experience, especially with the auto updating, all the time. Every time you go and, who knows what technology it's using to show the ads where they're coming from or what other third parties they've installed, maybe even their database library is updated weekly, and it's a third-party library, so it's not really that different.
Yeah, no, that's fair.
I'm not trying to make excuses. I'm just it's a problem in general,
Yes.
Yeah,
and I don't know how to solve it.
Yes. Agreed.
I'm all for, if you want to be able to block it for anything, right? I don't want a random website to access my camera. I don't want them to access my mic without permission. I could see the argument that some people might want them not to access. I mean, people turn off JavaScript. There's people who just turn it off. Say, hey, a site should not be able to access JavaScript unless I allow it. And that's totally reasonable request.
And I do think it's something that the browser builders can do because, I mean, for instance, Safari on macOS does have a feature where it's like, hey, this tab is using more battery or more memory than we typically expect from a tab. Do you want to close it? And sometimes you say yes, and sometimes you say no, but at least then you know what's going on. So I think that definitely it's something that at the browser level, I think we could provide affordances for people just to know, what's going on inside of their browser and make decisions.
File a feature request.
Yeah,
Absolutely.
On all the browsers.
totally. And,
On all
and
of them.
speaking of features, I'm actually curious, Greg, to hear what is your favorite WebGL or WebGPU API, and what is it, and how does it work, and what does it do?
I'm not even sure I know what that question means.
Well, as in, what you don't know, what's your favorite? What's your favorite API? Do you like 2D rendering, 3D rendering? Do you like playing around with lighting? I don't know. Do you like doing stuff with textures, shadows? I don't know. What's your favorite thing to do?
I like games.
Okay, you like games. You like building games.
I like games, so I want to enable games.
Okay.
And I love seeing artists use this tech to make things I haven't seen before. So if you go look at, I don't have one off the top of my head, but you go look in Steam and you look at all the games, I'd like to see some of those be brought to the web if possible, or at least to enable them. That's the place that I guess find the most inspiration.
Are there tools for game developers for cross-platform kind of ports over to the web via WebGPU or WebGL?
There are. I mentioned Unity before. That they already shipped long ago WebGL and WebGL2 exporters for Unity games, and there are websites. I think itch.io, for example, has full of games that you can just click on and they'll run in the browser.
Yeah. You effectively get that for free. I mean, sure, there's probably a little bit of...
To some degree, there might be things like networking that you have to use the right libraries. If you're using something that's native only, you'll have to figure out a way that it's going to run on the web. The biggest issue that people have with games is that games are often, especially big ones, are often like, a gigabyte download or multi-gigs. And then that's not really a web thing. So the biggest problem I think developers have is they start just making a native game and I can push this button and get a web app. Okay, I'll push it. But did you actually design this for the web? No.
Right.
So I think the games that will actually do well are going to require web-first design. And I haven't seen too many of those.
Yeah, I'm in the same boat there. By the way, side note, I read your recent blog post about Tears of the Kingdom, and I would love to maybe have a separate conversation with you about that game because we have different takes on it, Greg. Different takes. Both being huge fans of Breath of the Wild. So maybe if you have time, you can stick around afterwards and chat with me about that. But I'm thinking about your teaching. You spent all this time, you've written all this stuff for WebGL Fundamentals. Is WebGPU Fundamentals.org, is a domain held? Are you rewriting?
It's already there.
It exists and it's done.
It exists, and it's not done, not even close. But I'm working on it. If I get lucky, work will give me some time to work on it. But doing it on my own, it's going to take a long time. I think I calculated to get all the same lessons from WebGL Fundamentals to WebGPU Fundamentals would probably take another 2 months of full-time work. And so that's a lot of work. And
that's a lot of work.
It's a lot of it redoing it all because you don't want to keep it. Obviously, you have to do. It's not just like copying it over verbatim and kind of translating. You also this would be better if I did it this other way. Okay, let's spend some time on a new diagram, things like that.
Seems like something that Google would be incentivized to allow you to work on.
Well, I think they would be, except that there's just too much other stuff I need to do.
Other things that need doing.
Yeah.
So what is your 9 to 5 in terms of what's your marching orders there? Are you down there implementing WebGPU implementation?
I am.
So the Maps team hasn't they haven't sequestered you to help with their migration?
I think, no, they're mostly like, yeah, get your low-level work done so our guys that render the maps can get their work done. Right.
So you're lower level than the low level. So we got the real low level guy here, Mel. This is nice. What about us high level folk? What's the best on ramp? I mean,
to me, the best on ramp would be go to 3JS, 3js.org, click on the manual button, and read. The first page will get you some cubes on the screen. Just as an example, you can probably pick load a GLTF file, which is a format for 3D files. They're easy to find online, and then once you know how to load one and display it, then you can start putting 3D together. You can all do that in an hour or two of looking up, or you can ask your favorite machine learning thing, how do I do this? And it'll probably tell you.
Make sure it has access to the internet so it's not outdated, because at least with WebGPU, it's a moving target at this point.
With WebGPU, no, but if you use a higher level library like 3JS, there's plenty of tutorials that are not out of date.
What about on the gaming side? If I want to get started with gaming in the browser as a creator, what's your go-to?
That's a hard question. There's something called Play Canvas I've never used. It's one of the few full web-based, web-first engines, but I haven't actually built anything in it. Unity is obviously very popular, and you can just click the button, export, and you'll get something. It just comes back to that thinking about the web when you're designing for the web, as opposed to just like throwing in all of Grand Theft Auto assets level in there and then saying, hey, you got to wait 6 hours while you download this before you can start playing.
Plus you got to worry about that new fee structure,
The other one is exactly. The other one is, for me, like games, a lot of times, it really depends on what you want to make. You can prototype it in a much simpler way with the Canvas 2D API or one of those others. Especially if you're making a 2D shooter or something like that, just get something working before you go crazy and turn it into 3D. I don't know if you've ever seen, like, there's something called a fantasy console, the most famous of which is called Pico 8. And it's kind of emulating, it's not emulating, but it's kind of like, hey, somebody gave you a Commodore 64, make a game. And the point is that with this limited system, that it only has 32K of memory, the screen is only 128 pixels by 128 pixels, it only has 16 colors, you free yourself from, oh my God, how am I going to make this look as good as as Elden Ring? You just keep it simple, get it done. And so people find that a way to start, and then they might start there with a prototype, and then once they got something, oh, this is fun, fine, let's make it beautiful. And we'll take it to another engine.
This is really cool. I will add this to the show notes. These are really neat games just on their homepage.
Yeah. I'm curious, if you think that there's a future or maybe even a present where, you have generative AI basically creating the next Angry Birds, you know what I mean?
It's already happened.
Okay, it's already happened. Could you tell us the story?
This is from Chat GTP 2 or 3. Somebody said, hey, write me some games in JavaScript, and they described the games, and they made you had to squint really hard because they made them low-res. They made a tiny little Zelda adventure game. They made it was like, okay, there's a block on the screen that represents the player. There's a block on the screen that represents enemies. I want the enemies to go to the player. If they touch the player, he loses the hit point. If if the player strikes one, she gets a gold point. Those kind of things. So, and they went through all the prompts they had to use to get it. And this was old. This is 3, 4, 5 years ago. My mind might be bad.
Yeah, you're way behind it, Mel. Come on.
Yeah, I do remember that. But I guess my question was really specific to using JavaScript, in the browser, right? Creating these amazing, rich, browser-based games. Yeah.
Getting it to an amazing level. Yeah. It seems obvious.
That's the trick.
It will happen. You'll ask Mid-Journey to make my art, and you'll ask, some other thing to write your code, and it'll just work. I'm sure people are working on it. And I know there was some post where somebody made a Magic the Gathering card generator. And I'm sure they could make a card game generator to and then glue those together. There was also a talk, this is not AI related, but there was a talk where somebody made a slot machine generator, and they actually published 1,500 of them.
Wow.
until they got taken off the store. But they gave a talk about it at GDC.
That's hilarious.
And they had made it so they just typed in a couple keywords like, unicorns and candy canes, and it would make a slot machine with unicorns and candy canes and publish it.
That's hilarious that it got taken off the App Store. Why? What's the reason? And this is why, for anyone listening, this is why it's really important to bring these technologies to the open web. Like, no one should be able to take down your app or your store, or like there shouldn't be like this Billy Gate, like, stopping your creativity. Like, you want to publish 1,000 websites, like, knock yourself out. Like, I think you should have the right to do that,
Yeah, totally. As for the App Store, I think the App Store is both, I don't know, they have some limits. I have no idea why. They just thought 1,500 apps, nobody published 1,500 apps. Something fishy is going on here. I have no idea. I'm not the person who decides.
Yeah, but maybe that's going to be the new normal for in the world of kind of bot creation, right? Like, it's, I don't know. We're going to greatly exponentiate the number of stuff that's on the web. And with that, we're going to have to figure out how we're going to curate it. Like, I think curation is like our next big problem. Like, how do we surface like important stuff? How do we filter like signal from noise? Like, I think that's going to be our next challenge, both like in every genre, film, art, like all the things,
You probably just ask the AI, hey, what's the good stuff?
Yeah, to be meta, right?
Yes, let them curate themselves for us.
Let them curate themselves for us. Really, Jerod?
I mean, why are we working so hard?
Oh my god! I agree. That's just gonna. It's gonna be like, all right, well, man, I'm feeling really lazy. I need to take a shower, but I like don't feel like washing my hair. And it's gonna be like, well, can I? My first thing will be like, oh, can I get a bot to do that? Like, is that going to be my new, like, can I, like, is that going to be our default to everything?
Pretty
like,
much.
Can I use AI for that?
Well, we'll end up like the people on Wall-E, up in the spaceship where they're just like, they don't do anything. They just kind of float around on their pods and get overweight.
Good Lord.
I am really excited about all that stuff, to be honest. Just, you mentioned generating the games and there are times when I want to make a game. The artist may be scared of this, but where I needed assets, I need a character to move around, and I need a forest of trees and paths and a castle. And at some point, I can just ask, hey, make this. I don't know if that's good or bad. I'm not trying to make a judgment. I think, I don't think you're going to get the style that you want, a cohesive style for any time soon, maybe, where a real artist that you hire or if you are an artist to have a vision is probably not going to come from AI soon, but I don't know.
Yeah. I would agree. I'm very excited about like the assistive elements of AI. Like, that's huge. I would love a team of engineers like working with me, like for free minus the cost to the planet, like, right, at any time of day. Like, that would be great. Like, are you kidding? People and the engineers that are smarter than me too, like that know more programming languages and can fix more bugs and then they create them. Like, all of that sounds great. So,
well, that leads me to my final question for you, Gregg, a serious one. Why have you not created a game since 2007?
Oh, wow.
Yeah, that's a good question I ask myself every day. And I talk to friends, hey, you should make a game. And then, we don't do it. One of it's golden handcuffs. You come to a big tech company and you're like, oh, what? I don't have to crunch and I get paid a lot more. Another is that the industry changed. Like, since the last game I shipped was 2007-ish, right? The iPhone came out in 2007. Like, mobile games became a thing. Free-to-play games became a thing. When I came to Google, I mentioned that I came to write a game engine. That was because at the time, Unreal actually cost like $1 million to use it. And I don't remember if Unity might have been free, but it didn't have the reputation yet for, this is something you should use. So I was like, I came to Google to make an open source engine. That all changed. Now there's two, they're not necessarily free, but they're free to use to prototype at least, and to even ship. It's only like if you make a lot of money, they want some money. And there's things like Godot, and there's a whole bunch of other engines out there now that weren't around back then. So that's changed it in multiple ways. It's made it easier. So theoretically, if those existed back in 2008, then I probably would never have come to Google, and I would have just tried to make something. On the other hand, they've also made there's like, I don't remember what the number is. There's several thousand new games every day. And so it's just much harder to stick out to look at that and go, I have an idea that's going to sell. Oh, wait, I'm going to put 3 years in. It's going to sell 5 copies. I've had friends that do that. They made a game, it looked beautiful. They shipped it, I think they sold 80 units.
Yeah.
And, that was 2 years of their life. So games have always been that way. They're like trying, I'm going to be a rock star.
It's a moonshot. Yeah.
Yeah. Finding a way to be confident that I'm going to make something that's going to have a market and is something that I like making. I want to make something that's unique, and having a unique idea is also. I'm not complaining about anybody else's game, but there's so many games that are just like, that's just Mega Man reskinned. That's just, they call them Metroidvanias. Yeah, I played Metroid. I don't need to play it again. I want something new.
Yeah.
Well, that's how I feel about modern music, modern movies. There's just a lot of, they're remixes, but they're like not inspired remixes. They're just like kind of like shallow clones.
Yeah, I'm not saying I don't get enjoyment out of them, but
yeah,
I would like to do something that somehow sticks out, at least in my head. I know a lot of designers, they probably think their game, it's completely different. And I'm like, but can't tell. At a glance, maybe if I got into it, I could tell.
Do you watch that show on Apple, Quest something?
I have not. Mystic Quest, I think
Mystic
it's called.
Quest,
something
yes.
like that.
Yeah, I haven't watched it either. Why, is it good?
Yeah, I watched a few episodes. It seems interesting. It's like, for example, like Silicon Valley, that show on HBO. About the tech industry and startups. I can't, it's very triggering for me. Like, I cannot watch that without like thinking, oh my God, that's like 50 people that I know are just like that. I have like, it's really hard for me to like sit through that show. I haven't watched anything past the second season because I was like, oh my God, this is too much. But I feel like the same way about that show. It's just too much like work. I'm just like, I can't, like, I watch TV to like,
because they work at like a game dev company. That's what the show is. It's like a group of people that are creating video games.
Right. It's just, there's too much similarity with like how I work, so, but yeah, I was just curious, if you were a fan. But
I have not watched it. There is a book that I just read that was recommended by a close friend who's also a game developer called Tomorrow and Tomorrow and Tomorrow. And I was kind of shocked that it has like, I don't remember if it's 70,000 or 120,000 reviews on Amazon. It's like, wow, I've never heard of this thing, and apparently it's pretty popular. But it's about 2 kids who meet in like junior high school, and in college they make a game company. And I was reading, I'm like, this is my dream. Why didn't I get to live this life? Anyway.
You kind of have.
Well, I did.
Yeah, you have I
Yes.
think, honestly, if you ask me, I mean, if you're someone who's contributing to the web platform at a low level, like you have a legacy that I think is cooler than creating games, in my opinion, because you're enabling others to create games. So you're like the baseline, you know what I mean? So think about it that way. You're upstream now.
All right.
I don't think he's convinced.
Yeah.
He's over there thinking like, okay, I'll think of it that way. But he's not really thinking about it that way. He's over there thinking about his game.
It's like you want to be the director and you're making the cameras. Yeah.
He's like, I don't want to be writing scripts, What's the director and the camera person going to do without a script? Greg, you're writing the scripts, so.
I think writing the scripts is the thing. I'm making the pencils.
That's right. Really low. He's as low level. He's pretty low level.
All right. Anyway.
It needs to be done.
Okay.
It needs to be done.
Well, I think what you need to do, Greg, is take WebGPUFundamentals.org and hand that off to ChatGPT. You've already written the first version. Just tell it to port WebGPL, WebGL over to this. And I'll spend my time creating the next great video game. I think that's your move. I don't know about the thought of handing it over to ChatGPT or whatever has crossed my mind. But the thought that all I'm doing is writing stuff to train ChatGPT, because nobody's actually going to come to the site. They're just going to ask ChatGPT, and it's going to tell it what it learned from my site. But you know what? That's fine, because that's just the way the world's going to work in the future.
Right.
All the kids are going to ask. They're going to ask their favorite large language thing or AI, and it's going to train them.
Right.
And that's just the way it is now.
In that case, you're not even making pencils. You're like mining the lead.
I'm teaching our overlords.
Jeez.
Yeah, exactly.
Jeez.
Well,
Oh, man. Well,
we've come full circle somehow, or haven't, but we need to close down. Any final questions, Amel, before we let Greg go?
I would say that everyone should at least spend 15 minutes checking out this website. I think it's pretty cool. WebGPUFundamentals.org. Check it out. It's solid. No pun intended.
Yes, please check it out and help out if you want. You're free to write an article. It doesn't have to be my thing. I don't know that anybody ever will write one, but yeah, it's all open source. You can submit a PR if you find a typo or you want to write an article or you want to translate. It's also set up to be easy to translate. So there's already, I think, 6 or 7 articles have been translated to Chinese and 2 to Japanese already. And yeah, people volunteer. So that's awesome.
Dope.
Very cool. Well, here's my final word. If you are out there building games on the web, or if you're using WebGL or WebGPU for anything cool, contact Gregg, let him know, thank him for the underlying work that he's been doing, and even just enabling folks like the 3JS folks to do what they do, which perhaps you're building on top of. So I will submit that to you. I know that that can go a long way when you feel like you're just down there toiling and maybe only the AI crawlers are going to be reading what you're writing. It's not a good feeling. So hook Gregg up with some props for enabling so many of us to build awesome things. I will link up all of specifically the game-related stuff, as well as the book you mentioned, all the things, if you're interested in itch.io, Pico 8, etc., in our show notes, as well as, of course, WebGPUFundamentals.org, so y'all can visit those things and check them out for yourself. Gregg, appreciate you coming on the show, for being a good sport, letting us pick on you a little bit, and schooling us as much as you can. I know that we couldn't quite go as deep as you can go, but we appreciate you joining us today.
Thank you so much for having me. It was great. And yeah, check out the site if you want to actually know how to do it, because it's not something I think I can explain in a
he was about to say in a podcast, but then he changed his mind. That was pretty funny.
Exactly.
You can't see his mouth,
That's
everyone.
fair.
I saw his mouth. He started to say the word pee, and he was like, all right, yeah, no. I get it. Sometimes I wish our podcast had this like accompaniment, where it's like, here's like the AR version of our podcast, like, where like we can share screens with you. But, I think it's just as important for folks to understand how to talk about technology without a screen, because I think for me, the most interesting conversations I have as an engineer are with my colleagues, when we're not sharing a screen. And so just want to put that out there.
Cool. Well, my last word, even though I said I was going to have a last word, is that podcasts aren't great for everything, different mediums for different things. What we can do, though, is we can expose people to new ideas and introduce them to places that they can go and extend their knowledge, such as WebGPU Fundamentals. So hopefully we have done that for you. Hopefully Daniel Buckmaster, at least, is happy as he requested this episode. But I think there'll be more than just himself. All right. I'm going to say goodbye before I continue talking even more. This is JS Party. I'm Jerod. That's Amal with Gregg Tavares. We'll talk to you all next time. We have an epic Changelog++ bonus coming up for you. In fact, it deserves one of these.
Funky, go!
Yeah, that's on point, because Gregg and I hung out to discuss our opposing reviews of Zelda, Tears of the Kingdom. A must listen for our fellow Zelda fans out there. If you don't have access to that sweet Changelog++ feed, get in on it.
Changelog++. It's better.
No ads, bonuses like this, discounts on merch, plus you get that warm, fuzzy feeling that comes when you directly support the creation of podcasts you love. Check it out at changelog.com/++.
No! What are you waiting for? Do it!
Next up on the pod, it's our last episode of 2023. Amal and the gang learn what's new in JavaScript from TC39's Daniel Ehrenberg. Then we're on break until our New Year's party, first week of January. Thanks again to our partners, Fastly.com, Fly.io, and Typesense.org, and to Breakmaster Cylinder for the steady stream of amazing beats. If you dig our tunes, find them on your favorite music service by searching for Changelog Beats. That's all for now, but come back. We'll be partying again next week.